Alright, here's your Target 2C quiz key. So, start with number 1. I give you a graph and ask you to write the equation. So you got top 9, bottom is 3, middle is 6, starts in the middle, has a period of 6 pi, so 3 pi, right, yep, so we got this guy here, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And the curve that we looked at looked like so. Three to 4, 5 it was. Okay. Middle, okay. Alright, so just set up the question here. So you had this curve, and you were asked, if I could sketch it, to write the equation of it. Back at 6 pi, it was in the middle. Okay, things I notice, I don't know, it starts in the middle and goes up, so sine is going to fit it very nicely. You don't need a horizontal shift here. The period is 6 pi, so 2 pi divided by x is 6 pi. What does x need to be? Well, solve for x. 2 pi equals 6 pi x divided by 6 pi. Divide by 6 pi. 6 is 2 times 3. So the pi's go, the 2's go, and you're left with 1/3. That's x. X is 1/3, so sine of 1/3 pi. That takes care of the change of the period. Let's see, the normal sine curve, right, goes like this. Has a high of 1 and a low of -1. I need, and the amplitude here is 1, from middle to top is 1. This curve has an amplitude of 3. So if you modified the original sine curve and did a vertical stretch by 3, it would change these guys right here to 3 and then -3. And then, how far do we have to move all of these things up? Let's see, well, if the top was at 3 and the bottom was at -3 and the middle was at 0, what do you add to all of those numbers to get these guys right here? So it looks like if you add 6, you get those. So after you make the adjustment to amplitude and multiply by 3 to make the amplitude 3, then you can add 6 to shift it up. And that is your answer to number 1. Okay, number 2. Graph the following equation, label the scales. So we want to graph y equals 2 cosine theta plus pi over 2 minus 3. So we know it's cosine. We know there's 3 transformations. You got the left, pi over 2. This guy, the times by 2 happens first. So you got v stretched by 2. So you're going to adjust the amplitude, and then you got this shift down 3. So if you think about what cosine starts out looking like, it looks like this, right? The top is at 1 and the bottom is at -1. If you do the vertical stretch by 2 to start, that's going to make this guy a 2, make this guy down here a -2, and the middle is still at 0. And if the next thing you do is move everything down 3, well, you take all these numbers, right? You're going to slide them down 3. So that guy would be at -1. That guy's going to be at -3. And that guy's going to be at -5. So as we start to build this graph, we know where the top, middle, and bottom are. So you got -1 is the top, -3 is the middle, and the bottom is at -5. The period here isn't adjusted because there's just a 1 next to theta, so the period is 2 pi. The last thing we have to do is move everything left pi over 2. So I'm going to do kind of a preliminary step here. I'm going to say, what if we didn't have the shift left? What would the graph look like? Well, if we didn't have the shift left, this is a cosine curve, the graph would look like this guy. So if you didn't have the shift left, you would have this graph. So everything's got a shift left. Pi over 2 units. You'll notice this distance, the distance between these markers, is all pi over 2. So everything has to slide left. And you could continue this graph on. So if everything slides left, pi over 2 units, well, this guy here is going to move right here. This point here is going to move right here. This guy here, left pi over 2, puts it right here. This guy here, left pi over 2, puts it here. This guy here, moving it left pi over 2, puts it here. So we have our new curve. There we go. That's all we'd have. Alright, that moves us to number 3. So let's see, number 3. They give you the graph. We need to know the amplitude and the period, and then we're asked to write an equation. So rough sketch. Top's at 30. Bottom's at negative 30. Which means the middle's at 0. Starts at 30. 24 is the... looks to be the period. 24 here. 48. So the period length is 24. 30, 36, 42. Okay, so we're still putting together the graph. 6, negative 30. Not totally drawn to scale, but... So we're definitely looking at a cosine curve. The amplitude is 30. Okay, I think half this distance here is 30. Your curve looks like this guy. Okay, so it starts to repeat itself at 24, so we'd say period equals 24, amplitude equals 30. Yeah. Alright, so you got the period and amplitude. Now you need to write a function. This thing starts at the top. It's going to be cosine. You don't have to shift it. Cosine. Let's see, the period. Well, we know the amplitude is 30. There is no vertical shift because the middle's still at 0. The middle really tells you about that vertical shift. So 2 pi divided by the unknown needs to be 24. So solve for x. X is 22 pi over 24. So pi over 12. Pi over 12 times theta. So y equals 30 cosine pi over 12 theta. Okay, next. At the back side of this, that whole conveyor belt deal. But basically, you got a package or a spot on the belt here. It goes around, makes 1 revolution in 4 seconds. You're supposed to track the height of that package. This has a height of 0. The radius of the wheel is 3, which means the top has a height of 6. So if you think about what this graph is going to look like, here's 4 seconds. You start at a height of 6 up here. Okay, 2, 1, 3. After 1 second, that's a quarter of a revolution, you should be at a height of 3. 1 second, height 3. 2 seconds, you're down at the bottom here. And then you're back up to 3 right here. And you're back up to 6. So you should look at that and go, hey, that's just a cosine graph. That's shifted up 3. The middle tells you where it's shifted. So it's a cosine. It's shifted up 3. The amplitude is 3. All we have to do is adjust for the period. The period is 4. So 2 pi divided by what is 4? So the answer is pi over 2. So pi over 2 theta. Yes, that is it for number 4. Sketch a graph for 2 periods. Well, we could keep this going, I guess. So I think that got a little lazy. So the x-axis would be time in seconds. The y-axis would be meters above ground. Okay, so 8, 6, 5, 7. Oops. So there's 2 periods of it. Write an equation for this situation. We've got our equation here. Okay, last problem. Number 5. Cool. It's about tides. They give you a graph. You got a starting height of -2. The top is at 6, which means the middle is at 2. Period of this guy is 12 hours. 12, 6, 3, 9, 15, 18, 21, 24. Okay, so one period is 12 hours. So the graph's going to start to repeat itself. There. Points on the graph. Let's see, -2. Let's see, it's 6. That's 6. 3, it's at 2. So you have a picture of this graph on your paper. I'm just working at sketching it real quick here for you. Okay. So that's the graph we're looking at. Write a rule to model the height of the water. Well, it's I'd say it's easy, but it's cosine, right? It starts at the bottom. So, your regular cosine graph goes like this. Okay. If I put a -1 in front of cosine, it'll give me this. So that's the first thing I'm going to do, is I'm going to put a negative in front of cosine. Also, the amplitude of this guy is, this distance here is 4. Both of these are, okay? So the amplitude is 4, so I'm actually going to put a -4 out there. So that would mean this guy here was -4, this guy here was 4. Now you just got to shift it. And you'll notice, well, the middle is at 0, the middle of this guy here is at 2, so you got to shift it up too. Horizontally, the only thing we have to change is the period. The period is 12. 2 pi over the unknown is 12. Okay, solve for x, you get pi over 6. So it's cosine of pi over 6 theta plus 2. And that is your final answer.